Hello, my name is Ilias Batzogiannis, and I will present you our research, which I have contacted with Dr. Hadjikranioti, named Changing Students' Attitude Towards STEM by Educational Robotics and Digital Games Programming. So, what was the problem that led us to conduct this research? Former researches have shown that the classical method of teaching being used all these years doesn't get the students close to science, technology, engineering, and math, also known as STEM. Although there might be some students that are interested in learning STEM, they soon change their mind because, first of all, STEM is difficult. Second, they can't connect what they learn with the real life. And third, they learn how to solve highly complicated exercises, but they really don't understand the true nature of science. All these have led us to the growing shortage of researchers of natural sciences from the European market, and to creating a society that consists of more and more scientifically literate citizens. In our attempt to change this trend, we decided to use educational robotics and digital games programming. So, what are we trying to achieve? We are trying to alter students' attitude towards STEM, to enhance their problem-solving skills, to teach them how to cooperate, to teach them how to follow instructions, to enhance their creative thinking, and to engage them in programming. So we are making an attempt of finding out if educational robotics and digital games programming can help us to achieve all these goals. In this presentation, we are focusing on how does educational robotics and the programming of digital games alter students' attitude towards STEM. So why did we choose educational robotics? Because it has been proven by other researches that helps in increasing students' interest. It is easy for the teacher to use. It can be used in better understanding of STEM. It initiates students in programming. Students learn about STEM without really understanding that they are learning at the time, and students learn by inquiring. And we chose digital games programming because it enhances students' solving techniques. It is easy for the teacher to use. It initiates students in programming. Students learn about STEM without understanding that they are learning. Students learn by inquiring, and it gives them a strong motivation of creating something that their friends are going to play. We can say here that both methods have a lot in common, although they may seem to be completely different. We have decided to use the same method in both courses, which is the learning by inquiry, in order to provide to the students initiation in the scientific research, scientific skills acquired by exploration, and the joy of discovery and creation. The implementation of our research took place in Platon School of Katerini, a private high school in a city called Katerini in Greece. 27 students of the first class of high school took the course of educational robotics, and they were divided in groups of 4 or 5 students with specific alternating roles, and 30 students of the first class of high school took the digital games programming course, and they were divided in groups of 2. The tools that we used for the robotic course is Lego Mindstorms if3, because they have been used in other researches providing good results. They can be used to construct a lot of different robots. Students are used in playing with Lego, and they are really easy to use. They have a really easy to use software, and they are relatively cheap. You can see here a picture of the rover that we used in our missions, and you can also see a picture of the software of the Lego Mindstorms C3, and you can see that there is no coding in order to make the robot move. Kodu Game Lab is the tool that we used in our digital games programming course. It is developed by Microsoft, and we chose that software because it has been used in other researches providing good results. It is also easy to use because there is no coding needed also in this software. The students can create the scene, the story, choose the heroes they like, and it has relatively nice graphics, and it is free. You can download it from Microsoft's webpage. In order to make our robotics course more interesting for the students, we created a scenario about some missions that NASA has hired your team to create a rover that will be sent in a new planet that was discovered recently by NASA. And every mission has its goals in order to make it decide by itself while being on the planet and making decisions without you programming it each and every time. In order to measure the impact of our courses on how does students' attitude towards STEM change, we created a questionnaire which was answered by the students before and after taking the courses. The questionnaire consists of 7 plus 14 questions in Likert scale, categorized in 5 categories, which are 7 questions about themselves, 5 questions checking if the students are attracted to physics and math, 4 questions checking how students feel or react during class, 3 questions checking if the students consider STEM important, and 2 questions checking if the students think that STEM is easy. Now I'm going to present you the results of the statistical analysis, which was made using Minitab's statistical software in 2 different groups, robotics and games programming. We want to check what impact the sequence had on both groups. The scale used to assign the data was -2, -1, 0, 1 and 2, and in order to explore the change of attitude, we performed a paired t-test for the difference of post and pre for robotics and digital games programming. We will present here the results of one question of each category. And from category 2, we chose the question about I read science book and articles. In figure 1 and 2, we can see the ranking for each student. In question 2, for robotics and games programming, squares represented the answers in the pre-test, while circles the post. The longer the lines connecting the two signs, the greater the impact. As can be seen in here, both methods had a great impact in students' attitude, and the statistical analysis of the robotics method gives p 0.015, which is less than 0.05, and for the games programming method a p less than 0.01. In order for us to claim that there is a statistical measured change in pre and post answers, p must be less than 0.05. From category 3 we chose the question 5, which says that I care about science class. In figure 3 and 4 we can see the net change of post and pre as bar charts for robotics and game programming. In this question, both methods also had a positive impact in students' attitude. The crossbar indicates the post mean while the dashed line indicates the pre-mean. As it is seen, the post mean has moved to more positive answers. The statistical analysis for the robotics method gives a p equals to 0.049, which is less than 0.05, and for the game programming method p equals to 0.036, which is also less than 0.05. From category 4, the question that we chose was question 11, which says that I use what I learned in science class in everyday life. Figure 5 and 6 represent the net change of post-pre as bar charts for robotics and game programming, as we saw before. In this question, the results are a little different. We can say that the robotics method didn't have a statistically measured impact. The dashed line is within the crossbars in figure 5. But on the other hand, the game programming method had a large impact. The crossbar has moved to more positive answers. The statistical analysis for the robotic method gives a p equals to 0.307, which is greater than 0.05, and for the games programming method, the p is less than 0.01. For the category 5, the question chosen is question 12, which says if science class is easy. In figure 7 and 8 we can see the net change from post and pre as before for robotics and games programming. In here we can say that both methods had a positive impact in the students, with the games programming method showing more positive results as it is in from the crossbars. In this question, the statistical analysis for the robotics method gives p equals to 0.05, and for the games programming method, the p equals to 0.022, which is less than 0.05. As an overall conclusion, there is a positive change in the children's attitude towards STEM. According to their statements, they have started to observe natural phenomena and try to investigate the reason why. More often than before, they think that science class is easier than they thought, etc. Comparing the two methods, digital games programming seems to have a more positive influence in student attitude towards STEM than robotics. It seems like innovative learning applications, in this case educational robotics and digital games programming, can influence the students' attitudes towards STEM. But the research will continue with more students in order to verify our results. Thank you for watching our presentation of our research called Changing Students' Attitude Towards STEM by Educational Robotics and Digital Games Programming.